Describe the transformation to the linear parent function fx that will generate this function. Now just a reminder, okay, oops, where are we at? Alright, cool. So the very first number is a. If a is negative, that's a reflect across x, and again, using this information, right? So if a is negative, right? So and then 3 is greater than 1, so we just had this. 3 is greater than 1, that's a vertical stretch. Vertical stretch. Okay. On yours, there's supposed to be these parentheses here. Whoops. Right. So anyways, it's supposed to be horizontal, and then it's 2. So again, greater than 1, horizontal compress. The plus 6, remember, it's a lie, so it's left 6, and then down 4. Alright. And then, same thing here. Okay. So identify the domain, range, X-Intercept, Y Intercept of the linear function described by the equation. Okay. Now, this is linear because there's no exponent, so this is linear. So the domain and the range are negative infinity to positive infinity, always for linear. X-intercept and Y-intercept. Now you can look at the graph over here. The X-intercept, where it crosses the x-axis, is at negative 6, 0. Bless me. Y-intercept, look at the graph. 0, negative 2. Okay, that's it. Alright, so, again, on all these are supposed to be parentheses. Alright, domain and range, once again, this is linear. There's no exponent, so it's linear. Domain and range, well, domain is still negative infinity to positive infinity. The range, negative infinity to positive infinity. X and Y-intercept. Alright, well, the X-intercept on the x-axis. And then the Y-intercept, 12, 0, 12. Again, just look at the graph. Alright. Now on yours, this looks a little different. Let's keep having to fix this. So this should be like this. And then this is a 3. Alright, so using that graph, identify the domain and range. Now once again, if there's no exponent there, it's linear. You can graph it and see it's linear. So the domain is negative infinity to positive infinity. The range is negative infinity to positive infinity. X-intercept and Y-intercept. Okay. So let's graph this thing so we can see the x and the y intercept. Graph. Let's type it in. Control divide. We need 1/2 in front. Okay. Parentheses 2 parentheses x plus 3 parentheses parentheses minus 1. Alright, now you can see the x-intercept is -2 and the y-intercept is +2. But if you press menu 5-1, you can know for sure. So see how it says 0-2? That is the y-intercept. And a -2-0 for my x. That's a little graph of it. You don't have to do that, but x-intercept, -2, 0. Y-intercept, 0, 2. Alright, next page. Let's fix this again. So there's supposed to be a parentheses right there. And that's a 1/2. And there's another parentheses. Alright, so domain and range. Now, notice that means it's quadratic. Quadratic is going to look like this, right? A parabola. So, domain and range. Now, if we have that graph, we should type it in so we can get a look at it. Okay. Four parentheses, 2 parentheses, x minus 1/2 squared minus 1. Alright. Cool. So, for domain, the domain for sure goes forever to the left and right when it's a parabola. But the range is not like that. Look on the graph. It doesn't go down forever. It stops right there, right? What is that vertex? Menu 5-1. 0.5, -1. Now remember, you can get that out of the equation, the vertex. You use C, D for the vertex, right? So the vertex is +1/2, -1. Remember, C is a lie. So the furthest down it goes is 1/2 or 0.5, and it goes up forever to infinity. And we have to use brackets because it includes that number. Now they're asking us for the x-intercept and the y-intercept. Let's see what we got here. We're going to press menu 5-1. Okay, x-intercept where it says 0, 0.75, 0. What else? Let's go to the left. 0.25, 0. And then our y-intercept, 0, 3. Alright. Now, number 6. Describe the transformation. Again. Describe the transformations. So again, out front, A is 2, which is greater than 1. That's a vertical stretch. One-third is my B, right? And it's less than 1, so it's a horizontal stretch. And then C and D. Remember, C is a liar, so it's 9 to the right. And then down 5. Alright, now we're talking about a cubic parent function. So now we're talking about cubed. It's a little different. Okay. Now, again, A is out front, right? So if A is 1/2, so that's less than 1, that's a vertical compress. There's no B, and C is a liar, so it's actually right 1. And then that plus 1 is up 1. Again, if you know where A, B, C, and D are, you just get to use this to help you out, okay? This might be different. It might have squared or cubed, or it might have, absolute value, or it might be in the bottom of a denominator, or bottom of a fraction. Don't matter, okay? As long as you know where A, B, C, and D are, you should be able to do this using that little chart. Alright, where we at? Okay, identify the domain and range. Now, for that 3 means cubic. Cubic goes forever to the left, forever to the right, forever down, and forever up. So, the domain and range is negative infinity to positive infinity. Okay, X-intercept and Y intercept. Now, I don't think that's exactly -2 right there. So let's go to the graph and graph this thing. New document. Don't save. Graph. Okay, 4 x plus 3 caret 3. Go to the right. Minus 2. Yeah, it's not exactly -2. Let's press menu 5, 1. Now, our y-intercept is 0, 106. Okay? So, y-intercept, we know is 0, 106. That's pretty big. But let's go to the left till we get there. Ooh. Negative 2.21 comma 0. Yeah. Alright. So you got to be able to do domain range, X-intercept, and Y-intercept for all these. Alright, so this function. Now how many x's are there? 1, 2, 3. That's still cubic. Okay, even though you don't see the cubed, the little 3. If there's 3 x's, that's like a third power x. Key attributes, including its domain and range. So again, just like the last one, forever to the left, forever to the right, forever down, forever up. So domain is negative infinity to positive infinity. Range is from negative infinity to positive infinity. We need the relative min and max. So let's type this in so we can get that off the graph. New document, don't save, graph. Menu 5, 1. So let's figure out the local max. There it is. 0.107, 0.205. Local max. Alright, and then the local. Okay, that's max. Local min. Go to the right. 1.56. Negative 1.02. Okay. What else? X-intercepts and Y-intercepts. Let's find these X-intercepts. There's 3 of them. 0. Negative 0.50. There's 1. Keep going until it crosses again. 1, 0. And then the last one where it crosses, 2, 0. Okay, what about y-intercept? Let's go back, tell it the y-axis. 0, 2. Alright, we got the min-max x and y-intercept. Cool. And again, this seems to be fixed. So it should have been written. Oops. And then, what are we doing? Now this is absolute value, so it's going to look like this, right? Domain and range. Now, whenever we did this, remember it goes forever to the left, forever to the right. So domain, negative infinity to positive infinity, but the range is not. Let's take a look at the graph. New document, does save graph. Now, it starts with -2, and then those vertical lines are absolute value. Please remember, what you need to press is the book right here. Book, enter for ABS. There's your absolute value. For parentheses, x minus 2. And then after that, you press +1. Now, you see how this goes down instead of up? Our range is going to go down forever, all the way up to that vertex. Okay. And then how do I figure out the vertex again? Remember, vertex is C comma D. Remember, C is a liar, though, right? So that would be -2, 1, except +2, 1, because C is a liar. So when you're looking at this, okay, it starts down at negative infinity, comes all the way up to this y value, which is 1. So negative infinity up to 1 with a bracket, because it touches at 1. This is the highest point it gets to. It's the max and the vertex. Okay, then what are we doing? That's the domain, that's the range, X-Intercepts. Let's take a look. X-Intercept, menu 5.1 as usual. Keep those X-Intercepts real quick. 1.880, 2.130. What about that y-intercept though? All the way down to get to that y-axis. 0, -15. Alright. Cool. The function on the graph or the domain range has inequalities. We're going to do it with interval notation every time. Yeah. Alright, so domain and range. If I have the vertex, well, I can tell you the vertex by looking at these two numbers or looking at that point right there, right? Just remember C is a lie. So instead of -4, the vertex is +4, comma, -5. And guess what? 4, -5 is this point over here. Cool. Is that a max or a min? It's a min. It's at the bottom of the what looks like a V. And then domain is going to be always for these types of absolute values. It goes forever to the left, forever to the right. So negative infinity to positive infinity. But the range, the furthest down it goes is negative 5. So bracket negative 5 because it includes that point, not an asymptote. Okay, so negative 5 up to forever up, forever up. So that's infinity with a parentheses. Okay. Identify the transformations of these rationals. Now remember, rationals look like this. They're weird, right? You gotta graph them. Wait, where's it in the graph? Identify the domain and range. Write the equations of the asymptotes. There's not a lot of room here, but we will do our best. Alright, so vertical asymptote is always x equals a number, and it's the c value, just c's a liar. So x equals 3. The horizontal asymptote is always y equals, and you're using the letter d value, which is 5, and not a liar. So when you're doing domain, okay, it's from negative infinity all the way till this x equals 3, but it can't equal 3 because that's the asymptote. So 3 union 3 to infinity. Okay, and in the range, you're using the horizontal asymptote. It does not touch y equals 5, so you're doing negative infinity up to 5 union 5 to infinity. Alright, we're going to write smaller now. Alright, so for my vertical asymptote, now there is no C here, so vertical asymptote equals 0. Horizontal asymptote is the D value, which is negative 3. The domain, oh whoops, x equals 0, horizontal asymptote, y equals negative 3. So the domain, negative infinity to 0, 0 to infinity. The range, negative infinity to negative 3. Once again, there's supposed to be parentheses down here, so this is what it's supposed to look at. That's what it's supposed to be. So, well, there we go. So, for the vertical asymptote, x equals the opposite of this, which is 8, positive. Horizontal asymptote is y equals the d value, which is 1.5. So, domain, negative infinity to 8, union 8 to infinity. This is barely fitting. Sorry, there's not a lot of room here. Negative infinity to 1.5, union 1.5 to infinity. Okay, again, sorry it's so small. Okay, down here, I just rewrote it because it was getting too hard to... Okay, so what are we doing? Identifying the domain range and any any intercepts, okay? So you know how to get the vertical and horizontal asymptote. So the vertical asymptote is x equals the opposite of negative 1/3, positive 1/3. So that means the domain is from negative infinity to 1/3 union 1/3 to infinity, because it does not touch 1/3 because it's an asymptote. Horizontal asymptote uses the letter d value, which is 4. Y equals 4, so the range is negative infinity to 4, union 4 to infinity. Okay. Let's get these intercepts. Let's graph it. New document, don't save. Graph. Alright, so we have a big old fraction. Negative 1 on top. Go down. 6 parentheses, x minus another fraction, 1/3. Go all the way to the right, plus 4. Hit enter. Menu 5(1). Now this is your y-intercept because x is 0. 0, 4.5. And you can kind of see it right there. But we can't see, well, you can see where the x-intercept is right here. It looks like 0.5, but let's see. Oh, it's not 0.5, it's 0.375, 0. Menu 5(1). Okay. Now 18 and 19 we're skipping, but at the top, now these are exponential, right? So remember, exponential looks like something like this with an asymptote. Okay. So what are the transformations? Once again, you're still using this. Looks a little different. Okay, if you remember from the notes, okay, it looks like this. The only real difference, besides where x is that you have a k for growth and decay. Okay, let's take a look at this. Got a up front, so if a is 5, woo, boy. A is 5, greater than 1. That's a vertical stretch. Whoops, why do I keep doing that? Vert stretch. Okay. And once again, there's supposed to be parentheses in there, so sorry about that. This is supposed to be 2 parentheses x plus 1. So that means b is 2. So, dang it. If b is 2, that's greater than 1, horizontal compress. Okay. If this is plus 1, that's a lie. So left 1. And then down 3. Cool. Now, on 17, if a is a negative sign out in front of the base k value, then that means a is negative, reflects over x-axis. And then b is negative 3, so if b is negative, reflects over x-axis, and greater than 1 is a horizontal compress. Now there's no C value, but there's a letter D, which is up 5. Okay, there's no C. Okay. Skip this part. Multiple choice, yeah. Now you can graph these in your calculator so you can see them. Alright, so let's graph these. Let's do this. So if you graph these, you can see the answer, you can see the table, sorry. Control T. So we're seeing which one gives us this. So the points we're looking for, let's say this one and this one. So we're looking for -1, 0, and then 0, 6. -1, 0, and 0, 6. Boom. That's it. Easy. Okay, but if you graph the rest of them, they're not going to give you the same 2 points. Okay, number 22. Which equation shows an absolute value? Sorry, let me put this right here. Control T, check for these points. Alright, 22. Which equation shows an absolute value function? The vertex is 5, -3. Now, remember, this is in the equation, typically. Okay. Alright, so this is supposed to be written like this. Negative. Again, these are written weird. So check it out. -5, 3. That's +5, -3. You could also graph and then menu 5, 1. And then you can do, check where the vertex is. Okay, last page. Woo! Alright, so what are the... Describe the transformation. Okay, so 2 at the front is a vertical stretch. So not horizontally compressed, not vertically compressed, not horizontally stretched, but vertically stretched. Yeah. And it should be not left 5, but right 5. And then down 2, 2, down. Alright, cool. So letter D. Which has no X-intercept and no Y-intercept. Now, if you graph, you'll see which one does not cross the x-axis. Start with letter A. Two, absolute value. 2x minus 5 plus 7. Now, plus 7 means it's just going to shift up, so yeah, that should make sense. See that? How it's way up here, and it doesn't cross this x-axis? So which function has no x-intercept, but it also says no y-intercept. Now if I hit menu 5, 1, there's my y-intercept. So it can't be that one. Okay. When you graph B, since it's squared, it goes forever to the left and forever to the right, so it's going to cross. Okay. What do you call this? Exponential function goes forever to the left and right, not up and down, but it does go forever left and right. It's going to cross an axis. Let's graph D. New document, don't save, graph. So control divide, -25 on top, 9x on the bottom. Now these asymptotes are the axis, so it does not cross the x-axis, does not cross the y-axis. So these rational functions that aren't shifted have no intercepts. Ooh, again, bless me. All right, last one. Which one goes down forever and then up to 2? Now, that means your letter D value should be a positive 2 to even get this. So it can't be that one, can't be that one. Plus 2 and plus 2, right? Now, if you graph these, okay, you'll see which one it is. Let's graph B real quick. Now you see how it starts at 2 and goes up forever to infinity. This one is 2 to infinity. That ain't it either. Okay? So we're left with C. Okay, but let's see it. Alright. Alright, see how this one goes down forever and then up to 2? That's it. Alright.